Vidyut Surakshit Bharat Abhiyan is a wonderful mission or objective that you have been carrying with the support of various government entities. And as the part of and co-organizer of this program, and on behalf of the South Asian Lightning Network as a chairman, this is my honor to have wonderful people, very eminent people working in the field of lightning as well as in the field of electrical safety, particularly in the low voltage end. So to begin with, I think we all are. Today's mission is a little bit uh, diff but slightly different than what Surakshit Bharat Abhiyan is. So we are talking today, we are taking up the issue where we have plenty of confusions and people are with little knowledge making some mess out of some products and so on. So we will be taking up this issue for the knowledge, for the greater, for the sake of greater knowledge of the audience we have today, participants we have today, although I know many of them are very prominent figures and they have been already working with all these things, but still there are certain confusions left in the among the participants as well as practitioners in the field of lightning protection system. So in order to discuss and interact with all the participants, we have organized, we have taken up this issue that what this non-standard or substandard type of lightning protection system or gadgets, and what are the standards, international standards, and what are the demerits and what are the good things about all these gadgets that are being claimed by various manufacturers and proponents of such products. So today I have an honor to introduce in this context to take up the issue. I have an honor to introduce Professor Dr. G.R. Nagabhushana. It's my I'm very honored to have him here today because he has produced so many scholars from the Institute of Mysore, and a very wonderful person who has wide knowledge of on lightning and high voltage engineering. So Professor Nagbhushan, he obtained his degree from the University of Mysore, right? BSc degree, BE, ME, and PhD from Indian Institute of Science at Bengaluru. And from 1965, Dr. Nagbhushan has been dealing with the various aspects of lightning and lightning protection from protection against lightning of transmission lines, satellite launch pads at ISRO, power equipment and insulation coordination. 1989, a project was awarded by ADA Bengaluru for to design and fabrication and commissioning of a unique lightning test facility having 4 million volts impulse lightning voltage generator and 200 to 200,000 amperes. That means 200 kiloamperes to 100,000 amperes and 200 amperes impulse lightning current generators representing the worst lightning stroke for lightning performance evaluation of light combat aircraft LCA of ADA. This facility was and even now being used under his guidance to evaluate the lightning performance of light combat aircraft. Hansa aircraft, other aircraft, and components of HAL, Bengaluru, Hyderabad, Lucknow, etc. I'm very much, apart from what the small bio here, I know quite well about Professor Naga, that he has been grooming so many bright scholars from the institute, and who are rigorously working in the field of lightning protection system and high voltage engineering. And it's my privilege to introduce Professor Naga. I think Professor Naga is with us today.
Thank
Professor
you very much. Thank you.
Thank you. Thank you. My privilege to be with you today. And then again, yes, my another honor, Professor Muhammad Jainal Abidin Abdul Qadir from Malaysia. He is the one of the key figures in Southeast Asia, working on the lightning and high voltage research rigorously for about 2 decades. He has been working with lightning. And of course, he is the member of IEEE, IEC, and so. I will read out his bio briefly here. So, Professor, I hope Professor Jainal is with us today. Professor Jainal?
Yes.
Oh, thank you. Welcome to the program, and I'm very much honored to have you here today with the mission that we have been organizing, conducting for several, I would say about a couple of years now. So Professor Jainal is the chair of Center for Electromagnetic and Lightning Protection Research, CELP, in Malaysia, and Advanced Lightning Power and Engineering Research Center, ALPER, Faculty of Engineering, University Putra, Malaysia. Professor Jainal received his B Engineering and PhD degrees from University Putra, Malaysia and University of Manchester, UK, respectively. He is a professional engineer, PEPC, a chartered engineer, CENG, and professional technologist, PTech. Professor Jainal is a fellow of Academy of Sciences Malaysia and fellow of the FIET, as well as an IEEE Power and Energy Society, PES. Distinguished lecturer in the field of lightning and high voltage engineering. He has authored and co-authored over 400 journals and conference papers.
317?
Yeah, please.
792?
He has, sorry, I thought I heard some noise. Okay. He has supervised over 28 PhD and 42 MSc students. His research interests include high voltage engineering, lightning protection system, electromagnetic compatibility, power system transients, and renewable energy. Currently, he is the chairman of NMC of IEC. This is the technical committee. 81, IEC 81, which is working for lightning protection system. So it is the international. I hope all the audience here, participants here, know about IEC. So he is the member and chairman of the NMC of IEC TC 81, looking after the lightning protection system, and local convener of CGRE Malaysia C4 on system technical performance, and this is what Professor Jainal is. Apart from this, he has been rigorously working to implement and endorse lightning protection system as per the international standard IEC in Malaysia, and he has been one of the most successful leaders to have this implemented in Malaysia. And he would, I think, today brief about what had happened, what was the story behind it. It's very interesting that how he had to struggle with the all these false claims and so on. Professor Jainal, you are most welcome, and it's my privilege to be with you today.
Thank you, Prof.
Yeah, and now I have an honor to invite Mr. Gopakumar, one of the organizers of today's program. But apart from the organizing, he has been rigorously working for the lightning protection system and awareness raising throughout the India, not only in India, but in South Asian continent itself. Like he has been training engineers in Sri Lanka, he has been training engineers in Nepal, Bangladesh, and so on. So I'm so much privileged today to have Mr. Gopakumar on this program. So he is the technical coordinator of Lightning Awareness and Research Center, LARC, Trivandrum. He is an electrical engineer by profession, and having more than 27 years of experience in electrical safety, lighting production, and EMI, electromagnetic interference, electromagnetic compatibility of electrical installation. He has conducted hundreds of site studies on failure of electronic equipment and presented papers in more than thousands seminars and training programs globally. He has published articles about safety of in various magazines, and published the book, The Missing Link, in the subject of electrical safety. He is a member in the working groups of IEC technical committee, and a member in BIS committee, building its Indian standard. So apart from that, I personally know Mr. Kumar was in Nepal. Since I am from Nepal, he was here for quite a few times, training the electrical engineers of Nepal, and he is one of the most popular and liked person among the engineers in Nepal. So I am very much privileged to have you here today, Mr. Gopakumar. So I think you are already there. So
Yes.
as we are all aware of today's discussion, I would like to request Mr. Gopakumar to take over to discuss about the situation scenario currently existing in India, because you are much aware of these things, although I know a bit, but not too much. Then we can discuss. We can invite Professor Naga, Bhushan, and Professor Jainal to have a discussion on that, and then we'll open the floor to the audience and participants and audience. I would like to request to put your questions, queries in the chat box so that we can take up those queries in the discussion session. May I invite Mr. Gopakumar to take over the...
Yes, thank you. Thank you very much, Dr. Sriram. Thank you very much for the introduction. I hope my screen is visible to all the participants. We are having a small problem in the chat. I think chat is not working for some of the people, but after the presentation, we will try to make it, set it right. So I hope the presentation is visible to everybody.
It is.
Now I will make a small presentation, a small introduction about what is CISA and what activity we are doing, and then I will go to the current, today's the subject. CISA is Center for Innovation in Science and Social Action. It's an NGO based out of Trivandrum, and in last 2 weeks, we have started a campaign called Vidyut Surakshit Bharat Abhiyan for electrical safety, to improve the electrical safety situation in the country. Now, sorry, a moment. Yeah, we are a passionate group of enthusiastic scientists, engineers, medical practitioners, and academicians, those who are working for the innovative ideas for a sustainable future. We were conducting or arranging a lot of programs. And CISA is also UN University, United Nations University accredited Center for Excellence for Education. We have taken up the electrical safety seminars or electrical safety classes due to the fact that a lot of electrical accidents are happening in India, and all of you are aware that we used to see fire accidents from buildings and people are dying. One of the reasons for such accidents are the electrical safety measures are not very well followed in our country. So this slide is about a study published by Mr. Takashi Honda from Japan about the electrical safety scenario in the countries, G20 countries. On the left side, what you are seeing is the safety scenario. Number of people, those who are dying out of 100 million per year. In India, it's average 723 people die every year out of 100 million due to electric shock. You can also see the situation in the other countries such as UK, Switzerland and Japan and other countries. Of course, they are very much developed, but 723 per year per 100 million is a big figure. And out of the G20 nations, the safety score given to India is just 16%. So you can understand how bad our electrical installations are. In this campaign, we are taking up a few selective subjects. There are about 9 subjects which we are taking up. One of the subject is lightning protection as well. But mostly the trainings are on electrical safety. What you should do to avoid the electrocution and fire from electricity. We have a group of technical members, Mr. Apau, Mr. James Kuti Thomas, and Mr. Vinay Nagdio. They are retired from the electrical inspectorates, and Mr. Patnaik from the Orissa Transmission and Distribution Company. Mr. Devdas Goswami, he is the consultant for International Copper Association. Mr. N.K. Mittal and Mr. Srinivas, they are electrical consultants. So we have a group of people, those who are doing the technical members are consisting of a group of people. And the program is also supported by several organizations such as BIS, CEA, Railways, Salnet, Spark, and like International Copper Association and all. Regarding CISA, we were actively working for lightning safety since 2006. Mainly the technical part, or mainly under the support from Dr. Muralidas and Dr. Shashi Kumar. We had started a center under CISA in Trivandrum called as LARC, Lightning Awareness and Research Center. Under the guidance from Dr. Muralidas and Dr. Shashi Kumar, the activities were carried out. We started the activity in 2006, conducted hundreds of classes across India. Dr. Naga Bhushana, Dr. Chantima Gomes, they were also a part of our activities, our training classes. We traveled to several cities and conducted several classes. These were during 2006, 2007, 2008 and all, already 15 years back. We also prepared and circulated handouts, the booklets for mass awareness, what exactly is lightning, how it is affecting, how you have to get safe from lightning. So these booklets were published. Posters, thousands of posters were published, mostly for schools and organizations. And we also organized the programs where the leading politicians, like here in the picture, what you are seeing is a program which we did in 2013, where the then Chief Minister inaugurated the program. So because of the involvement of top officials and other people, popular people, the media was covering our programs in a very good way. We also in 2014 and 15, we conducted a mass awareness class across Kerala for the school program. And thanks to Dr. Muralidas, he was the one who was traveling all over the state, and he was taking classes for school children. As a result, we have conducted several trainings in this particular case. In 2012-13, there was a news which came in the newspaper last year. It's a news from the State Disaster Management Authority of Kerala State. They said 2012-13 average death was about 72 per year, whereas in 2013 to 2018 it has reduced drastically, and 2019 only 4 deaths are happening annually average. To our knowledge, we were the only one, those who were behind creating such mass awareness programs in Kerala. Now, coming to the main subject of today's program, lightning protection. You must be aware that across India, once when we go from state to state, area to area, the idea about lightning protection varies between people. Between common people, this is a different situation. But the ideas within the engineering community is sometimes very low in some parts, and sometimes it's totally in a wrong direction in other parts of the country. So first, I will start with what exactly the Indian standard says. What is the lightning protection as per Indian standard? Imagine a building. I'm showing the top view of a building, the roof of a building. Now, the first part of lightning protection is to create an air termination system. An air termination system is intended to intercept the lightning, in the sense the lightning, instead of hitting the building, it is supposed to hit this particular air termination. There are several 2-3 ways of designing the air termination. If you have a flat roof, what is recommended is a grid. Say, for example, 15 meter by 15 meter. So there are also some more science behind it. There is a lightning protection level, a risk assessment, lightning protection level, and those points are there, which I am not going to explain. But in a simple building, a flat roof, you have to make a mesh at the top of the building. And if there are protruded items, if roof-mounted electrical or some kind of appliances or some kind of materials are there, such as, let us say, solar PV and an air conditioner chiller unit, in this case, these protruded electrical appliances require additional protection, such as a rod. Within the angle, the rod protects against direct lightning strike on these electrical appliances. And in addition, we have to make equipotential bonding. Equipotential bonding in the sense the mesh and the metal parts of these electrical apparatuses are interconnected. This is the normal way of doing air termination. Now, for air termination, designing, positioning of the rod, we also have the electrogeometric sphere principle, rolling sphere method, and the electrogeometric sphere principle, which is followed across the globe for several years, especially if we look at all our transmission lines, distribution transmission lines, the lightning protection of transmission lines. Millions of kilometers of transmission lines across the globe are designed with this particular principle, rolling sphere electrogeometric modeling. The second part of lightning protection is the down conductor. Let us say in this typical example, there are 10 down conductors. Multiple number of down conductors are necessary because we need to see that the lightning current is divided through different paths. As a result, I can see a comment. Please sync the slide with presenter to see the slide. I have a question, Mr. Vignesh. My speech and the slide, are they not syncing? Can you just switch on your mic and give me an answer?
No, it is.
It's working, sir.
It's working. Okay, thanks.
It's working, but many are saying that they cannot see the slide. Will it be better to do it like from your system itself, like sharing screen?
Yes, one moment. One moment. Yeah, I hope now it's better. Now you are able to see.
Yeah, now it's for me it is.
Yeah. So now the second part, as I said, it is the down conductor. Lot of down conductors, number of down conductors are required because the total lightning current shall be divided through different paths in order to reduce the effect of the lightning current. Then at the building, we need to have equipotential bonding. That means the down conductor and the electrical installation bus bars, earth bus bar shall be interconnected, equipotential bonding. And on the power lines and data lines, the service lines which is coming into the building also shall have surge protective devices. And every down conductor should have an earth electrode. So the calculations are given in the standard, how to design the earth electrode and so on. And in modern buildings, the easiest way is to make a foundation earthing. That means the structural steel, the steel reinforcement inside the building can be used as the earth electrode. So this is how the lightning protection system is designed according to the IEC 62305. Now, another important subject of this particular design is called as the electrical separation. Electrical separation in the sense, once when the lightning current flows through some of the conductive parts, there is a chance that the nearby metallic parts could be danger because of a spark over. As a result, we are supposed to measure the separation distance, and the electrical apparatuses shall be kept a little bit away from the down conductor. Say, for example, now I am showing you a typical example with the calculation. Let us say, just as an example, 1 meter is the distance between the air terminal and the metallic parts. What does it mean is, you have the building here, and this red color is the air terminal, air termination and down conductor, and the S stands for the separation distance. In order to avoid the spark over between, flash over between different objects, down conductors shall be at least, example, 1 meter away from the frame of the structural steel, electrical wiring, rebar, metal doors, metal windows, and so on. So this is also an important subject which need to be considered in case of lightning protection system. And here the exposed the in modern buildings, natural down conductors. Natural down conductor means the rebar by little bit of modification. The steel rebar itself is used as down conductor. As a result, the separation distance we are supposed to avoid. We need not have to calculate separation distance in modern building, and the recommended practice for high-rise buildings are to use the steel rebar or the natural components for the purpose of lightning protection. So this is the, I would say, a small introduction about what exactly is the Indian standard says. The Indian standard says there shall be a grid at the top. There is may probably some few rods depending upon your roof. Then there are several down conductors. There is an earthing system, and you have to make an equipotential bonding system. You have to have SPDs and so on. This is a very well designed lightning protection system. Now, what exactly ESE says? ESE in India. Let me say ESE in India because ESE sometimes used in other countries are a little bit different than what we do in India. So ESE in India, it consists of, imagine a high-rise building. At the top of the building, there is an attractive rod. So even from a little bit far away, you will be able to see the rod. There is an attractive rod. Then there is a down conductor. Normally, a 70 square millimeters copper flexible insulated conductor. Why insulated conductor? Because people say, because of the insulation, the current will go through the conductor without damaging the nearby things. So insulated down conductors are used. And there is one earth pit. So mostly the promoters of such system, they say this is a very simple system. One rod, one down conductor, and one earth bit. All your problems are gone. Also for industrial installation, imagine there is a large industry at the top of the building. There is a rod, there is a down conductor, and there is an earth electrode. And the danger again here is the high-rise buildings, down conductors are always routed through some shaft, especially electrical shaft. Along with the electrical wiring, the down conductors are also running. One of the classic example is my own building. I live in an apartment. Totally, there are about 28 floors, about 120-meter height building. There is an ESE rod at the top. The builder has provided it, and then the down conductor. It is taken through the electrical shaft with a lot of bends. Now, what is the claim of these people? They say, you have a building. At the top of the building, you put a rod. Now, this rod is able to cover, it is able to attract lightning up to a distance of 100 meter or 110 meter. That means you will protect not only your building, you will protect all your neighbors and if possible, the nearby buildings as well. And then they always say this is a new technology. By listening to the word a new technology, people will get an impression that, aha, that means the whatever explained in the Indian standard is an old technology. That is absolutely wrong. This ESE is not new. It is there existing since 1980s. It's already 40 years. The arguments and the claims and all these advanced things are going on for the last 40 years. It is so new technology. This claim is wrong. Then the ESE supporters always say, this is ESE is an advanced technology, active technology, modern technology, simple technology, and this has got less maintenance. And they lot of marketing words are used, and the claim is it protects up to 100 meters. So as a result, people are very much attracted. 100 meters, 100 plus meters, it will protect. And then there is a counter. So whenever there is a lightning strike in your building, the counter keep on counting the number of strikes. And you can look at the counter, say for example, counted the 10, there is no failure in your building and you can be happy. Then the fourth and the important point is, this is accepted in the French standard. There is a French standard, NFC 17102, and the ESE supporters claim that the French standard accepted this technology. French people are also intelligent people. They are not fools. They are also intelligent people. And if a French standard accept this technology, what is the problem in India to accept early streamer emission? This is the biggest argument which we face every day. So let us try to analyze what exactly the French standard says. The French standard. Of course, the French standard is in French language, which we are unable to read. So we have, I am looking at the translation from the UTE, that is, I think, the Spanish Standards Organization. There is an English translation available. Even if you Google, you will be able to download this particular standard. So I have made this picture in a color graphics. Now, this is the picture. How to install an ESE rod explained in the early streamer emission standard, which is the French standard. Remember, worldwide there is only one standard which accepted early streamer emission, which is the French standard. From the French standard, other countries also adopted it, like Spain, Portugal, and all the nearby countries. Now, this picture is the explanation how to install a lightning ESE rod in a building. It consists of one or more air terminal. This air terminal is the ESE rod, connecting components, down conductors. Remember, there are two down conductors, whereas in India, we always talk about one down conductor. Test joints, earth electrodes, foundation earth electrode. Foundation earth, in the sense, the earth electrode is connected back to the foundation of this particular building. Then you have the electric power cables coming inside. You have electric power distribution board. You have the telecommunication power distribution board. You have one or more equipotential bonding bars. You look at this particular picture very carefully. The down conductor is also connected to the bus bar. The down conductor is also connected to the earthing of this particular electrical appliance. The down conductor is also connected to other part. The down conductor is also connected to some electrical appliance at the top. This is not my picture. This is the picture from the French standard, the only available standard in the world about ESE. So if we analyze this particular picture and if we read and go through this particular picture very carefully, actually the standard is talking about a lightning protection system similar to what is written in the Indian standard, but the only difference is this particular thing. The item number 1 is the only difference between the French standard and the Indian standard. Indian standard explains all the other matters, like you have to have multiple down conductors, you have to have equipotential bonding, and all those things are there. So the question is, what exactly is this? In India, this is not the way people are educating. People are educating totally in a different way. You put one rod, the rod protects 100 meters. You take a 70 square millimeter wire and put it on the earth bit. So all the energy from the lightning will go through this insulated conductor without destroying any or disturbing any of your other appliances, and it goes to the earth. This is what people educate in India, but this is whatever you are seeing in this picture is the explanation from the French standard. Now let us go into deep. The French standard again. The French standard also says if you have a high-rise building, then the high-rise building you have to have the additional protection against direct lightning strike for the height of 20% of the structure more than 60 meter. So that means tall high-rise buildings more than the top 20% has to have or any other means must be implemented at each facade, if you have facade at this building, according to a valid standard. Actually, this is a very clever wording. The only valid standard is the IEC 62305 or the IEC 62305. What NFC standard says, for high-rise building, you make a equipotential bonding or you make a connection according to a valid standard, which is the IEC standard. Furthermore, a minimum of 4 down conductors interconnected by a ring conductor when applicable shall be used. Unfortunately, these are not done in India. Now, again, go back, the standard. Protection level 1+. That means the ESE rod is additionally connected to the metal structure or reinforced bar of the building used as a natural down conductor in addition to the dedicated down conductor included in the system. This part says, if you wanted to increase the efficiency of your system, you have to connect your down conductor also to the structural steel. That means you use the natural component, which I have explained in one of the previous slides. Whatever explained in the IEC and the IS standards, they are repeating. Now, level of protection I++, the roof is protected level 1+ with an ESAT having a radius of protection reduced by 40%. So these are the explanations in the standard. Similarly, another subject explained in the French standard is the subject called electrical insulation of or separation distance. I explained what is explained in the Indian standard in the previous slide. Now the same calculation is also repeating in the French standard. So your electrical appliance and your down conductor system or your ESE system has to have certain separation distance. Say for example, here you have the early streamer emission device. S1 is the separation distance between the electrical installation and the down conductor. S2, another separation distance. S3, another separation distance. So exactly what is there in IEC standard is explained in this particular French standard. Now, you see here, this is the explanation of the separation distance. Now, the French standard explains in this fashion, which you are seeing in the picture. Not only the French standard, the French, Spain, Portugal, and all the countries, those who have adopted this particular ESE rods, they are explaining that this is the way you should do a lightning protection system in your building. Whereas when it comes to India, the system is totally wrong, totally different. People say you have a rod, a simple rod, advanced modern rod, it attracts lightning from 100 meters and send it to ground without disturbing your building. So ESE in India generally, basically it follows a nice story. When you listen to the story, it looks very good. Aha, 100 meters. So this advanced rod attracts lightning up to 100 meters and sent it to soil. And this is the story which is explained in India: one rod, one down conductor, and one earth pit. The question is, Indian ESE vendors don't know about French standard. I think none of these vendors so far in the last 40 years, none of the ESE vendors in India, it looks like they didn't read the standard properly. Because so far, I have not seen any ESE vendor in India who has explained the correct way to a client. They always say that you have one rod, one down conductor, and one earthing or one earth pit. So don't they know? They don't know about the French standard is the question. Then why are they making false claim about the ESE rods installed in India? They say that the ESE rod in India, this as per these two pictures, they are as per the NFC standard, which is absolutely wrong. Why are they making false claims? This is a natural question. As an engineer, we have to be take care. We have to take care of the installation as per the standard. Whatever the standard written, we are supposed to follow. Whereas these people are not at all following the standard, and they are coming out with a nice story. Now, what is this ESE, and what do we mean by ESE's efficiency? When we compare a normal rod and a normal Franklin rod, or the system explained in ISIC 62305 and the ESE rod, people say ESE is advanced, modern, so it can attract so much lightning. This comparison, the efficiency of a lightning rod, I'm not going much into the physics part of this, the science part of this particular subject, because the science part is not an engineer's job. It is the job of a scientist. So its efficiency shall be accepted by the scientist, the scientific community. What the ESE people say is, the ESE proponents, supporters say is, there is a normal rod in your building, and this rod is emitting streamers into the cloud or towards the cloud. These are emitting streamers. Whenever a downward leader comes from the cloud, the ESE rod is emitting streamers. The normal rod is emitting streamers. In comparison, this blue line is the streamer. See, in compared to a normal rod, the early streamer emission rod is very much fast. It is faster than a normal rod. As a result, within the same time, the ESE rod is able to send the streamer to a longer distance. And this longer distance, they say, even though the rod is 1 meter height, because of its advanced efficiency, this effective height of this particular rod is delta T into 10 to the power of 6, whereas this delta T is the time advancement or the time difference between the emission happening in a normal rod and in an ESE rod. Actually, once when we go into the science behind it, this is a crooked science. So the effective height is converted to radius based on some complex formulas. Now, scientists across the globe, not only one or two scientists, almost all scientists, those who are doing research on lightning physics and the lightning protection method, they have not accepted this theory. The arguments are delta T. That means I have a slide which I will explain you later what is this delta T. Then the speed of the early streamer, the 10 to the power of 6, because nowadays there were some reports which they say that with the high speed, latest modern cameras, people made some research, and the speed of this is not 10 to the power of 6, it is sometimes 10 to the power of 4 or 10 to the power of 5. Then these formulas given in the French standard, these 3 points, the delta T, 10 to the power of 6, and this particular calculation are so far unproven. Because once when somebody says that I have a new formula, then it is the responsibility of the of the person to show that his formula is correct. Until now, the ESE vendors are unable to prove this particular formula. Now, what do they do with respect to the testing? Delta T. How do they find out the delta T? Imagine you have a laboratory, and in the laboratory, first is you test a single rod air terminal. That means a normal iron rod, maybe 1 meter height of the iron rod, and then at the top there is a plate. At the bottom there is again another plate. Between these two plates, a charge is created. Once when the voltage is going beyond a certain limit, there is a breakdown happens. So they make a breakdown, and the time of this particular device, the time with which this particular device is emitting some kind of early streamers are taken, and this is called as the time of the single rod air terminal. Then they connect an early streamer emission device. The same time is the ESE time is also taken. The difference between the normal rod and the early streamer emission rod is taken as delta T, the time advancement of this particular the ESE rod. Actually, this theory nobody understood so far. The second part, as I said, from this delta T, you have the complex formula, and out of this complex formula, one of the point is the delta in meters. How much is the effective height? Delta T into 10 to the power of 6. This is also a complex formula. Now, what scientists did, they made a similar. There are hundreds, thousands of people, those who are making research on this subject, trying to find out, trying to evaluate whether these claims are correct or not. I am just showing you one example. Don't think that this is the only example. There are several examples. Because of the time, I am only just showing you an example. So we have in the laboratory, there is a plate, and there is the same setup is created. This purple color is a normal iron rod. Let us say iron rod in the sense the iron rod from the construction steel, the TMT rod, say for example, and then you have a ESE rod. So what scientists did, they connected an iron rod and an ESE rod, and if the theory, if the claim of ESE vendors are correct, if the ESE is more efficient, and if you put 100 strikes, out of 100, all the 100 strikes should go to the ESE rod. So they made the charge, they did the testing, and finally the result is, if the theory is correct, the iron rod and EST are tested simultaneously, all strikes should go to the early streamer emission air termination. But it is not so. It's about 50-50. In some cases, ESE will have 60, the normal rod will have 40. In another case, sometimes normal rod have 70 and the ESE has 30. So there is the claim of the ESE rod companies are absolutely wrong. This is one of the way which is proven. There are several research papers available in the internet. If you look at our chat box, you will be able to see all these papers. We have uploaded in the chat box. You can download all these technical papers. A lot of technical papers are uploaded. Then, as a result, the scientific community didn't accept these arguments, especially the delta T, the 10 to the power of 6, and the protection radius. As a result, ESE is not accepted in any of the recognized international standards such as IC, IEEE, NFPA, VDE, BS, and or whatever. Even in France, the actual French standard is 62305. In France, the NFC EN 62305 is the actual LPS standard. ESE is used without violating 62305. So if you look at the previous picture, ESE is used without violating 62305 in the sense they use the word coexist. Coexist in the sense you have a very good guard, which is the 62305, the conventional or the lightning protection as per the IEC standard. In addition to the protection, they make one more rod. That means the word which they say is coexist. ESE is coexisting with IEC lightning protection system. What do they say is you make a lightning protection as per the 62305 standard, and then you put an ESE in addition. Of course, if you have money, you can do that. Whereas when it comes to India, the situation is totally different. We are not talking about the testing which is recommended in the IEC standard. We always talk about testing from the CPRI. What I am showing you is an email correspondence between a consultancy, a large consultancy company, and to some of the government organizations. Remember, government organizations. The lightning, find out the ESE lightning arrestor provided for Gujarat MPCS. This is a multi-purpose cyclone shelter. That means it's a government project. In a government project, this ESE is used, and he is explaining how this is installed to another officer. And now, point number 2. ESE lightning arrestor CPRI test certificate, Government of India Society approved by Lab Ministry Power India. So that means the people, this gentleman says that the ESE rod is tested in a CPRI lab. So as an Indian, we have to accept. We generally think, this is tested in CPRI. Then what is the problem? Let us look at what exactly the test conducted in CPRI. The actual test which is recommended in the ESE standard, you are very well aware, that is the delta T. That means how much efficient it is. That is totally a different test. Whereas in India, there is a surge current generator. There are 2 generators. One is 40 kiloampere and one is 70 kiloampere. The generators are connected directly to the ESE rod, and maybe 3 pulse, 4 pulse, 5 pulse, 2 negative, 1 positive, 2 positive, 2 negative. Like the few pulses are given, and finally the CPRI gives a certificate. And you must understand that this is not a test made from a standard. This is a customer specific test. Customer specific test. Instead of this ESE rod, if I have an iron rod, and if I go to CPRI and say that, look, I have an iron rod, can you test it for 40 kiloampere? Of course, they will. If I pay the money, they have to test, or they will test, because this is a customer specific requirement. Now, this same test which is conducted in CPRI also can be done with an 8 millimeter thick TMT rod. All of you knows what is TMT rod. TMT rod is the iron rod which is used in the construction steel. The same test which is conducted for the ESE in the CPRI, it can be conducted in an 8 millimeter TMT rod, and the TMT rod will also pass the test. Does it mean that the ESE rod is equal to a TMT rod? So if people accept the test report from CPRI as an authentic paper for accepting the ESE rod, I would say tomorrow I will come out, I will go to CPRI, make a test with a TMT rod, and you should accept my TMT rod as well, equal to ESE rod. This is the argument, because whatever explained in ESE and whatever tested in CPRI, these are totally no relation between these two. Then what is the business behind it? Look at this. This is a tender in Maharashtra. 45 crores, not 1 or 2 rupees, 45 crores rupees worth ESE rods are they are going to install it in panchayats, hospitals, schools and all. Schools. What is the, look at the situation of the children. This is by the government. So the question to the government authorities are, look, we are a nation, we have our national standard. Why don't you respect our national standard? And if you have any problem with the national standard, you can write back to the authority and you have to ask them to change it. So we don't respect our standard and we go as per whatever we wish. This one, I got the video yesterday. You are aware that last week there was a lightning strike in Rajasthan, in Amar Fort. Initially, the report says 11 people passed away, and then there were some reports saying 16 people. I'm not sure whether it is 11 or 16. But anyway, yesterday, Aaj Tak made a news. This is from the news. I can send you the link if you require. So what you are seeing is an ESE rod installed in Amar Fort. So if the claim of the ESE is correct, why do people die? You should think about it. But the news had come in a different way. The news says only 1 rod is used in Amar Fort instead of 1. If you make 10 rods, the entire fort is protected. This is what the news says. But as an engineer, we should think that, okay, there is 1 rod. Then what happened to that particular rod? And this is supposed to protect hundreds of meters. What happened to those hundreds of meters? Nothing happened. People died. Air termination system. Now, ESE and National Building Code. The National Building Code of India in 2016 had written not to use non-standard lightning protection system. It was very clearly written. I will just explain you the background, why this has come. I was a member in this particular committee. So the draft of the standard has come in this fashion. I'm showing you the draft of the standard. All these documents are public. These are not secret documents. You can also find it out in the internet. Air termination system. The draft says early streamer emission air terminals shall not be allowed. Any other kind of air terminal, if used area within the angle of protection as per table 4 of the practice, shall be considered as protected zone. So indirectly, what it says is, if you have a rod for lightning protection, we are supposed to protect, or we are supposed to consider that the area within the angle of protection is the protected place. So what it says is, even if you use an ESE rod, you should consider the angle of protection and use it. This is what the recommendation. This is what is in the draft. But once when the draft is published for public comments, anybody can comment. So as a result, there were thousands of comments, and specifically regarding this particular subject, there is this document is available. You can download it and you can see it. One of the largest ESE manufacturer in the world, the company name, I'm sorry, you can read the company name. They made a comment. The comment, this detail which I have highlighted in the previous one, details should be more specifically explained to avoid any confusion. And what they recommended is modified word. Any other kind of air terminal like early streamer dissipation system, controlled early streamer emitter as per NFC 17102, if used, shall be considered as a normal conductor. So he is trying to make it more specifically. He says if these ESE and other things as per the French standard is used, then you have to be very specific. It has to be considered as a normal rod only. This is what he has written. And his comment, IEEE also discouraged the use of this system under clause 7.3. Now, this comment, once when this comment was analyzed by the committee members, then there were a lot of discussion, big discussions went on, and finally the conclusion is, who is this company who has made this comment? They are the world's largest manufacturer. And what do they written? They are writing that the only available standard in the world is wrong. Because if you read this, it's very clear. They say the only available, don't use as per this standard. This is what they have written. So the world's largest manufacturer says that the world's only available standard is wrong. So what do the committee do? The committee said, okay, accept his wording and remove the standard which he has put. So the committee accepted, and the recommendation from this world's largest ESE manufacturer, and put us any other kind of, look at the wording. The wording itself came from the recommendation of the ESE manufacturer. Any other kind of air terminal like dissipation system, ESE air terminal, CSE air terminal shall not be acceptable. So one word, the whole problem is gone. So this is the background behind the National Building Code. Whatever written in the National Building Code is perfectly correct, because the vendors in India, ESE vendors in India, anyhow, they are not even following the French code. Anyway, let us go to the next part. Now, this is so far I was explaining about the protection of a building or a factory or some kind of a structure, but there is a big propaganda going across India, which is more dangerous than the ESE rod. ESE rod, if somebody installed it in case of a lightning hit, his building is will catch fire or destroyed. That is his personal problem. But now we go to a public problem, a serious problem. In propaganda in India is, we have protected the whole city, protected lightning protection, protected cities, lightning protected villages, and one ESE rod protected up to 1 square kilometer. The ESE vendor says it's only 110 meter, but the supporters say, like the leader says 1 and the supporters say 10. So the ESE vendor says 100 meter and the supporters say 1 square kilometer. One rod protect 1 square kilometer. What you are seeing in the picture is an ESE rod installed in a farm or in an near to an agriculture farm. In open area, this ESE rod is installed. Now you can see there is a tree. And after 1 year, once when the tree grows, what will happen? The standard, French standard explains how to calculate the radius. It is 100 meter, but it is not always 100 meter. There are some calculations behind it. And now if we apply these calculations with the installation which is in the picture, you can be 100% sure that what this the supplier did is really nonsense. So NFC, this particular clause, it explains about the protected area. The protected area is always something plus or minus 110 meters. But the proponents, the supporters say each rod can protect up to 1.1 to 1.5 square kilometers, and you must understand that even in the documents of the ESE standard, these are not correct. Then again, the supporters, what they say? There are two technologies available. One is called as the lightning conductor. Lightning conductor is as per the Indian standard or as per the National Building Code of India. It conducts the lightning. Very simple. So lightning conductor. Then the second one is called as early streamer emission, which is called as a lightning arrestor. So the first one is lightning conductor and the second one is lightning arrestor. So one lightning arrestor protect up to 1 square kilometer. Actually, there are videos available in the YouTube. Sometimes the manufacturer, sometimes the supporter says 1.5 square kilometer. Sometimes they say 1 square kilometer. We have to really ask them. You fix this value. Don't try to change it every time. If it is 1 kilometer, fix it to 1 kilometer. Then we can have a discussion. So they claim up to 1 to 1.5 square kilometer, and then they say ESE is modern, advanced, new technology, and all the fancy words are used. And the last part, please look at it. There is no sound and no light in ESE rod. What they say is this rod will do something. As a result, lightning, sound, and light itself will disappear. To be honest, most of my friends, those who are in the lightning protection field, when we discuss, they are this is a real surprise. What kind of theory are you proposing? Then the second, the next points of these manufacturers are ESE is installed in Eiffel Tower, then Burj Khalifa. The performance of ESE is very good because it is installed in Parliament of India, Qutb Minar. This is installed. So these are the signs of good performance because Parliament of India is protected. And in Qutb Minar, ESE rod, there is an earthing. There is a counter in Qutb Minar which counted, I think, up to 10-15 strikes. I remember it is something about 25 strikes. The counter has counted 25 lightning strikes in this lightning arrestor or this ESE rod. That means 25 times lightning has struck this, the counter counted, and nothing happened to the building. That is the claim. But unfortunately, if you take one of this counter and shake it very well, then it will start counting. If you shake it 2 times, it will count sometime 20. So even without lightning, these counters are counting. That is another funny thing. Anyway, that is not our subject. And then the claim in Qutb Minar, earthing is done in a well. So you have a large well, and you have put some big plate into a well for dissipating the current. And another one video which I have listened recently, it was very interesting, very funny. One vendor, ESE vendor, says that he has worked in Germany, France, Japan, and other countries, and in Switzerland for a telecommunication installation they have installed ESE. And in Switzerland it is full of ice, so getting a resistance of a lesser value is very low. So they use cow dung in Switzerland for earthing. So in order to get 8 ohms of resistance, cow dung is used in Switzerland. Actually, what kind of if we really go into their wording, we won't be able to understand what they are talking. It's really in a pathetic situation. This is the slide. Lightning arresters are devices which arrest the lightning before it is formed, and hence there is no light and sound. There is no sound and light. This is a very special statement for India. But I should ask, my question to these vendors are, what kind of device is this? And you see, these devices are installed. The claims these are installed in I don't know what exactly is this ESE stadium in Ranchi. So the people, those who are watching cricket in this particular stadium, please be very careful. If there is a lightning, please don't go to the stadium because there is an ESE rod installed. Now the other theories, the new wordings which we never heard of, like hill lightning, jungle lightning, river-based lightning, coastal lightning, urban lightning, semi-urban lightning, carpet lightning. There are several words which, unfortunately, most of the people in the lightning protection field never heard of. Those attractive words are used during the trainings. Kerala is having coastal lightning throughout the year. This is somebody had made a statement that I made a research, and my result is Kerala is having coastal lightning throughout the year. And you see here one of the presentation, sound low VHF 1 to 30 megahertz. Sound low VHF 1 to 30 megahertz. Are they engineers or what kind of people are they? Because in our schools we studied very well that the maximum the sound is between 20 to 20 kilohertz. But what kind of sound is this up to 30 megahertz? Now, vertical and lateral strike. Lateral strike is having 10% current of vertical strike. In farmlands, especially in Bihar, the land is very open. Lateral strike will travel several kilometers and it is killing people. So lateral strikes are very danger. Then they say if you plant tall trees around your house, the trees will dissipate lightning. And then the next claim, a compound wall. If you have a compound wall around your building, the lightning will not, the lateral strike will not travel through the soil, so people are protected. So in your house, if you put a rod, or if you plant a tall tree, because the tree dissipates lightning, and around the tree, if you put a compound wall, the problem of lightning is gone. If we follow this particular theory. Basically, my question is, what kind of science are we talking? We are a nation with a lot of, from ancient days onwards, we have a lot of scientists and we have a lot of engineers, world-renowned engineers. And now we are making a proposal of something like a nonsense. And this is how the trainings happening in India. Look, school children are educated with these theories. 30 megahertz sound. What kind of sound is this? And vertical strike and lateral strike, jungle lightning, river-based lightning, and all these things. Lateral strikes are fatal in open space agriculture fields. Example, recent death in Bihar. So the explanation is lightning is coming like water coming from the cloud. Once when it touches the ground, it splashes. So lateral strike is like a splashing of water. So it flows a larger area and it kills people. Now, these supporters are also making a new and a dangerous system, a more dangerous situation. Of course, educating children on this wrong science is, of course, it is a big danger, but more than that is another more bigger problem. Dangerous installation supported and funded by government agencies. I repeat, government agencies. You can see a building somewhere probably in eastern part of India. Now in the building, you can see a wooden pole and something at the top. The item at the top is a cycle rim. Cycle rim is the cycle tire frame. So there is a wooden pole and a cycle tire frame. Now look, the wooden pole and the cycle tire frame. And this is called as a lightning protection system. Lightning protection for village, lightning arrestor for village lightning protection system, or some modern names they were calling on this. Such non-standard and unheard systems are proposed for people in order to save these children. Say, for example, there are children in a school, and imagine what will happen in case of a lightning strike in this wooden pole. Now they say this is a new technology made out of commonly available goods, out of a bicycle tire rim, and the components of this lightning protection are a cycle rim, a wooden pole, and a metal wire. Few of them can save the entire village. Remember, the initial propaganda is if you put, let us say, 5-6 numbers, your entire village is lightning protected. This was the claim which was originally came. And these cycle rim lightning protection systems are supported by reputed organizations and NGOs. They are funded and they are installing these kind of lightning protection system. And once when we told, once when we made an argument a few months back, 2 months back, that this cycle tire cannot protect kilometers and it cannot protect panchayat and villages, then they proposed the same people, they have proposed a new system. In the new system, instead of a cycle rim, they have proposed a GI pipe, and then there is a 0.5 meter long aluminum air terminal, some down conductor, and some earthing system. Now you read at the earthing system, GIMS pipe earthing, low cost but short life. So that means after 2 years, the earthing is gone. Will it work? Let us analyze. This rod, as per the theory which is shown in the previous slide, if we take a level 1 protection, protects up to a 13-meter pole, 47 degrees. So what I am showing in this dotted line, this is approximately the area which is protected. Now, the IEC 62713 says in case of a lightning strike in some kind of an object, you have to be 10 meters away from the tree, for example. Now you have a rod, and if you wanted to be safer, first is you have to be 10 meters away from this particular pole. So first 10 meter is gone. Consider the earthing system is a MS pipe and it corrode after some time. So first is you have to be 10 meter away from this particular pole. Now at the edge, the last place, because of the height of the person, of course, there is a chance of a direct lightning strike. So you cannot go to the edge. Then finally, you get a protected area, which is about 1.5 meter. So if we look from the actual view, so this is the rod. The orange color is the claimed protected area. First 10 meters you cannot go because of the step potential. Then you have about 1.5 meter, which is actually protected. The last orange place you cannot use because you will get a direct hit. So if these systems are installed, people during lightning, people should run towards this particular rod. Then they have to find out where is this 1.5 meter and stand on this 1.5 meter. If you go closer, there is a problem. So such dangerous systems are proposed across India. Another case, Cyclone Shelter in Orissa. This is the tender document. Cyclone Shelter, I have a picture I will show you. It's a normal RCC building. Probably the height of the building is 7 to 8 meters or maybe 10 meter, normal RCC building. You have to understand that people inside an RCC structure are protected. People inside a substantial building are protected, provided the metallic plumbing system and the metallic power lines are connected to the equipotential bonding system. So lightning protection, air termination, down conductor, and earthing is required for this particular building, not to protect people, it is to protect the building itself. So now what is done here? Somebody made a beautiful proposal. There is an insulated pole. The air termination mesh is running on the insulated pole. The down conductors are HVI isolated air termination. HVI means some kind of a special down conductor. And this particular down conductor, for example, it is a copper wire, 35 millimeter square high voltage cable. The cost of this cable is about 3,500 rupees per meter. So this kind of a lightning protection system is proposed in the state of Orissa, and I think several hundreds of cyclone shelters are protected with these kind of things. The question is, what are we doing? Who proposed this? You are building even without air termination, probably the people are protected. And this kind of an isolated protection is required, let us say, for example, a defense installation where missiles are protected or missiles are kept inside the building. Very special cases, you need to have this kind of a very expensive isolated lightning protection system. But somebody, I'm sure some European manufacturer very cleverly put these unwanted things. As a result, there was a big tender. It is a cyclone shelter. If we make a risk assessment, probably no lightning protection probably is required for this building. Even if it is required, probably the lightning protection level 4. The drawing looks like LPS for a high security explosive storage building. In terms, the terms used looks like products from Europe are selected. It is an international funded project. The estimate, I am sure it is between 15 to 20 crores. How do I calculated the estimate? Because the totally about 30,000 meters of this special cable is used in this tender, each costing about 3,500 rupees per meter. The cost of the cable itself is about 10 crores. So if the cost of the cable is 10 crores, all the other items together is at least double. So 20 crores average. And after 2 years, the installation looks really funny. This is the cyclone shelter. The cyclone shelter. Isolated air termination. And you look at this on the left side, there is a pipe, and through this pipe, this special down conductor is running. It is an established fact that down conductors must be fixed to the building very strongly. You cannot hang it loose because the mechanical forces created by the lightning is very, very heavy. If your fixing is not proper, then it could create an explosion. So you are supposed to fix it very firmly, whereas this down conductor is hanging through a pipe. Next. The down conductor, the very expensive, per meter 3,500 rupees. This conductor is hanging through the pipe, and it is hanging on the side of the building. What kind of installation it is? Number one, this protection itself is not required. You have provided a protection. Of course, probably the people are protected. But how these are installed? I'm not showing the installation of a 10 years old picture. This is very recent. It is installed, I think, only 2 years back. The entire thing is destroyed within 2 years. So this is the fact about, these are the fact about the lightning protection stories going on in India. Now I will try to cut short it. What exactly is required for protecting rural places? The most important is step potential. In order to avoid step potential, the conductor which is buried in the soil shall be buried across or around the building as a ring conductor. Ring conductor limits the potential difference, and this is much more better. The best way of protection is a container, but of course, container is very expensive. You cannot put containers at several places and ask people to sit inside it during a lightning strike. This is very risky. One of the proposal is, instead of a container, probably at half of the cost of a container, a metal shed can be made. But don't try to make a metal shed from tomorrow onwards. You have to properly engineer it. I'm just putting an idea. Another important point is you need to have ring conductors around the building, because one of the idea is to protect people, those who are outside the building, or people those who are coming towards the building, from step potential. So this is one idea. Probably all the four sides of the building can be covered with metal sheet. As a result, you achieve the particular safety. And this is how the ring conductor shall be extended. The first ring conductor is 0.5 meter below soil, 1 meter away from the shed, and the second one can be about 1 meter below soil, but 4 meters away from the building. So if you wanted to protect buildings with the thatch roofs, you can have one GI pipe, a commercially available, locally available GI pipe. If you use an MS pipe, probably the life is less. If you use a GI pipe, the life is probably a little bit more. You can find out the area of protection by the angle method, or you can also have a catenary wire around this particular, interconnecting these particular rods. As a result, the buildings are protected. But don't forget to put ring conductor. Protection of houses. or protection of schools. Don't remember to protect the children, those who are outside the building, because most of the time it is the step potential which is creating the problem. It is nothing to do with the lateral strike. It is called as step potential. Now, for cyclone shelters, this kind of RCC building, the people inside the building are protected, provided there is no metal plumbing and electricity inside the building. If there is a metal plumbing and electricity inside the building, you have to make an equipotential bonding. Otherwise, people inside are protected. Now, whatever the rod and down conductor which you are going to give for these kind of buildings are to protect the structure. Otherwise, lightning will strike the structure and the concrete or a piece of concrete may break. If electric lines are there, use SPDs. And the LPS is used for the purpose of protecting the structure. Now, this is my last slide. Lightning protection, ESE and the lightning protection system in India. Lightning protection is an amazing story for most of the users. The best story gets the award. What I wanted to explain to you, or what I wanted to show you is, imagine a client or an user wanted to buy a lightning protection system. He calls 5 vendors, and the fellow who makes the best story out of his attractive rod gets the order. This is what is going on. People respecting national regulations and standards are very, very less. Our standards and regulations are not respected. This is one of the reasons. Now, I would like to put an interesting point, one more sentence. On the left side, you can see 2 photos. And these 2 photos are called as a lightning protection system, called as lightning elimination system or dissipation array system. What they say is, the equipment on the right side, these 4 items are attracting lightning up to 100 meters. Whereas this item on the left side is dissipating lightning. That means the lightning will not hit you, it will go to your neighbor's building. So not only we are in India, so far we are talking only about this attracting system, but these dissipating systems are installed across a lot of our defense installations. And all these installations are unfortunately not protected. A lot of failures are coming. And the most dangerous part is educating children about the non-science or wrong science. By this, I would like to stop. Thank you very much. Over to Dr. Sriram.
Yeah, Mr. Gopakumar, thank you very much for this wonderful presentation. I hope most of the participants have got the basic idea of what is the difference and what is going on in India. And of course, if it is going on in India, it will definitely impact the whole continent, Indian continent. So that as a chairman of South Asian Lightning Network, I am very much worried that such non-science stories are going around without any scientific basis and as like a good storyteller. So I think India has to take, I feel a little bit pity on Indian part as, as a big country with a lot of scientists in the country. Such stories are going on and setting the examples in India that will definitely impact the neighboring countries. So this is a very, very sad part for these stories. Thank you very much anyway, Mr. Gopakumar, for this presentation. Now, I would like to invite to kindly comment on these things and have a presentation on what his experience is from Malaysia. I would like to invite Professor Jainal. Yeah, Professor Jainal.
Right.
Yes.
Yeah, please, over to you.
Okay.
Nagabhushna sir, the presentation, we can make this, Nagabhushna sir is next. There is a small change, sorry.
Okay, all right. So it's going to be Prof. Nagabhushana?
Yeah.
Okay. Sorry.
Please go ahead.
Now it will be my presentation. I am Nagabhushana speaking.
Okay, please, Professor.
Okay, 1 second. I've got a few slides.
Okay.
I must first of all say that the presentation by Gopakumar was very interesting, but the alarming situations raised by his presentation is really very worrying, very worrying. As Professor Sriram said, it's worrying not only for few people in India or few hundreds of crores in India, for the whole of South Asian population. It's really very alarming, very alarming. I can't stop saying alarming, because lightning has been known to cause a very large number of deaths, more than any other natural calamity in India, 2,000 to 3,000. But still, I'm not very confident about these numbers, because there is no authentic way of recording these deaths or injuries, in fact. In fact, if we take the data in USA, where the documentation is very good, they say that the number of injuries is approximately 10 times the number of deaths. If we accept that, in India it should be about 20 to 30,000 rupees, 20,000 people who are injured. But there is no authentic data at all. It's really alarming. I think we need to work very hard towards that. Now, regarding the question of ESE and its extremely doubtful performance, I've got a few slides. The title, of course, I have put as "Why Hesitation to Include ESE Lightning Arresters in IEC IS standards or any other national or international standards." Why are they not recommended for wide general acceptance? This is purely a technical assessment with my limited high voltage engineering knowledge. IEC IS 62305 do not accept ESE-based lightning production except when locations, down conduct systems, and earthings are strictly as per conventional Franklin rods, lightning rod systems. The number, the down conductors, the earthing system must be the same as for Franklin rods. Only then it is acceptable. That is a very good statement. And then, what are the claims of the manufacturers of the ESE? They say the streamers from the tip of the ESE leader streamer, it moves very fast compared to the streamers from a Franklin rod. Therefore, it contacts the lightning leader earlier and then therefore protects the surrounding area. These streamers are claimed to travel a much larger distance and bridge with the approaching leader much earlier than a Franklin rod. That means faster protection, larger area. Now, there is no field photography made available by these manufacturers using obviously high-speed photography to verify the above. Let them do it. I will be the first to accept it. They depend upon very highly debatable experimental work and results, doubtful experimental results because of the way the experiments are planned to claim superiority. I have given some instances below. In one set of the laboratory experiments, which have been claimed to show the superiority of the ESE system, is that a cloud was represented by a 2 meter by 2 meter copper plate mounted 2 meters above the tip of an ESE LP or afterwards Franklin rod. The flashover waveforms obtained indicate the time to flashover in case of ESE LP to be 10 microseconds earlier than in case of Franklin rod. Gopakumar also pointed out that. I have shown the possible figures here. The time to flashover is 10 microseconds earlier. But, and they have assumed that the earlier streamers travel very much longer distance in this time, 100 meters or more, giving greatly enhanced protection. How did they arrive at this 100 meters? They assumed the velocity of 10 to the power 6 meters per second is highly questionable. The time available for extra coverage, according to them, is 10 microseconds, which is the time differential between the flashover timings of the flashover wave shape of for the ESE and for the Franklin rod. Now, S is the distance in covered in 10 microseconds. If you take the simple product of velocity multiplied by time, it comes to only 10 meters. 10 to 6 meters per second multiplied by 10 microseconds is only 10 meters. How do they claim 100 meters? Am I or have they forgotten and inserted one additional zero? Zeros have no value normally, but here it has an enormous value. Now, in another set of experiments, the ESE lightning production scheme and the Franklin rod were placed well apart and equidistant from a HV rod electrode. 10 or more high voltage impulses were applied. 50% of the flashovers occurred to each of these ESP and Franklin rods. I hope people are hearing. Can I have a confirmation whether people whether my speech is being heard? Okay.
Yes, sir. We can hear you.
Easily.
Very good. Now, this, according to them, this completely proves identical performance of the ESP LP and the Franklin rod. So there is absolutely no superiority of the ESE LP at all, even for this small gap. Go further. Now, the other objections to these experiments, I have raised only a few, there are many more. The cloud bottom in real life is 2,000 to 3,000 meters above ground or the grounded object. Of course, the grounded object is also ESE or the Franklin rod. Therefore, 2 meters spacing between the ESE LP and the copper plate is absolutely inadequate, unthinkably inadequate. Note that the height of the ESE LP itself is 2 meters. And then how can 2 meters between the tip and the copper plate represent the height to the cloud? And then the electric field will be terribly different. Secondly, the copper plate 2 meter by 2 meters is by itself an equipotential, but the cloud is not an equipotential. So what sort of representation this? Now, the dimension of 2 meters width is also not at all adequate. It's not an equipotential. It's not adequate, both. Now, next, what was the voltage level used in these experiments? What was the percent probability of flashover at that voltage level? I'm sure every high voltage engineer knows that the flashover probability of a gap depends upon the voltage. For example, at a certain voltage, there may be no flashovers even if we apply 10 impulses. This is a typical number that we use in laboratories. If I go on increasing, at some level, out of the 10 impulses, only 1 or 2 may flash over. They call that 10% flashover probability. Like this, we can go to 50% probability level, which we call the critical flashover level. We go on increasing the voltage further, we get the 100% flashover level. So what was the voltage used in these experiments? And what was the polarity? For positive polarity, it will be different. For negative polarity, it will be different. But in real life, the cloud, the leader from the cloud is more than 75–80% of the times negative. So what was the polarity used here? Now, what was, yes, that's important. In reality, bridging is not with a cloud in reality, but with the leader tip, which will be 2,000 meters below cloud, maybe about 100 meters above the tip of the rod or the ESE situation. So now, I have shown here in this figure the sort of handwritten field distribution. In the case of a rod plane gap, it's a highly divergent field. In the case of a rod gap, the bottom rod representing either the ESE or the Franklin rod, the upper rod obviously representing the approaching leader, the field is very different. This is a handwritten just like that. If you take an actual plot or if you make a computer simulation, it can be found out that the electric field density at the tip of the ESE or the Franklin rod will be very much different and maybe much stronger in case of both the rods. Therefore, what will be the impact of this rod geometry, the electrode geometry, on these flashover characteristics? Will it still permit 10 microseconds deviation? And 10 microseconds at what voltage level, as I already mentioned. So, going further, there are other serious issues that are not in favor of ESE. Now, if ESE is, remember that ESE rod is supposed to be placed in the open atmosphere, either on top of a building or very wonderfully in an open field protecting large areas. But what about the influence of the uncontrollable, enormous variabilities of the weather, effect of relative humidity, temperature, moisture condensation on the ionization region of the ESE, rain and rainwater settling on the ionization tip even before lightning, dust collection at the tip? So what are the effects of these parameters on which we have no control? So each one of the above can very seriously interfere with the function of the ESE LP. Whereas a normal Franklin rod is not subject to these at all. So the behavior of that will be more consistent rather than that of the ESE. But we have to see the performance of the ESE rod under various weather conditions, first of all. The situation is that they say there's the or electron emitter. In fact, one of the manufacturers in India, in his pamphlet, says that the ESE tip emits electrons. He forgets that this will be at a positive potential. How can it emit electrons? It defies every simple knowledge of physics, every simple knowledge. That means he is simply dreaming, probably in a completely unconscious state totally. So in view of the above, in fact, these are only a few. There can be much more. For example, when the electric field intensity are compared between the rod plane gap and rod gap, the electric field intensity at the tip of the rod, ESE or Franklin rod, will be much higher. When the field is much higher, the time lapse may become much less. In fact, these old-time characteristics, as we call in high voltage laboratory experiments, is done very commonly in all good ME high voltage courses. Now, if the electric field strengths are much higher, it's likely that the time lag of 10 microseconds may become very small. Of course, subject to other parameters like the polarity, the presence of the dust, etc. There are other serious issues like that. So on the whole, I feel that the claims made on behalf of the ESE are in no way justifiable. Let me repeat, they are in no way justifiable. Therefore, the very strong hesitation in adopting ESE-LP will persist for times to come. This hesitation will be definitely 100% sure in the case of even reasonably learned people. But the common people, unfortunately, can be bowled by impressive terminologies and say, I know, unfortunately in India and probably in many other underdeveloped countries or developing countries, they are bowled by the terminology and they are bowled by the fact that it's an imported technology. And rather than trying to understand what they say, whether what they say is really correct or not. And then the real life situation, as I mentioned earlier, the weather conditions seems to be impossible for lab experiments. Long gaps, humidity, temperature, settling of the dust, etc. With large gaps, it's quite impossible for laboratory experiments. Because if we want to think of testing a 10-meter gap, we will need at least about 4 to 5 megawatts output pulse, that too in outdoor conditions. If given 10-meter gap may not be adequate to represent real life conditions, maybe 50 meters, 100 meters may be right, in which case we must realize that the highest voltage available in the whole world anywhere is about 5 megawatt simple generator, one of which I have seen is probably in Les Renardier in France itself, maybe in IREC, Canada, that's the Institute for Research in Quebec, Canada. Maybe Brazil has got one laboratory built by the famous scientist who's engineer, I forget the name immediately. And the only way of proving, to my knowledge, ESE-LP satisfactorily appears to be real life high-speed photography in the field and all physical and weather conditions. That means that at least there must be 20, 30 photographs of that kind, covering all the weather conditions. Now, subject to this, only we can even think of seeing the possibility of an ESE-LP being scientifically acceptable. But from the available data, from the available experiments, and ignoring the very faulty claims, accepting only the real life situations, real physics of the situation, is not at all acceptable to my mind. As an academic man, I'll be the first to accept what appears to be true experimentally and by proper scientific logic. I hope I have made my points clear. If there are any other questions, I'll be happy to answer you. I must thank you, Professor Sriram, and also Gopakumar and all the audience for listening to me. If there are any further questions, I may be able to answer.
Thank you so much, Professor Naga Bhushan, for your wonderful presentation, making all these experimental results clear among the participants. And I'm really happy to have you here today. Now,
thank you very much. Thank you very much.
Yeah, we'll get back to you. I think you'll be able to stay for some time.
Yeah, surely.
Okay. Before I invite Professor Jainal, I have seen a very prominent and world leader on working on lighting protection system, Professor Chandima Gomes, all the way from South Africa. Professor Chandima, am I audible to you? Can you hear me?
Yeah, sure. Thank you very much, Sri, and I'm really enjoying
Thank you.
the
Thank you.
presentations, and I'm so happy to see Prof. Nagabhushan after many years. He's one of my mentors, and Prof. Namaskar to you
Namaskar,
and
namaskar.
Madam.
Yeah, Madam is always behind him.
Yes, I know that very well. So, hope that you all are doing well, safe and sound.
I hope the same of you and your family.
Yeah, sure, we are well. Life is going on, and Prof, you are exactly the same by appearance as I have seen you 15 years ago.
Thank you, thank you. Very kind of you. Wish you all the very best, you and your family.
Okay, and thank you very much, Sri, for this nice opportunity that you have given
Chandana,
me.
yeah, I'll come back to you again a little bit later after Professor Jainal's presentation so that you can comment on what is going on.
Sure.
Yeah.
Definitely.
Professor Jainal, I hope you are ready with the presentation. Sorry that I invited you a little bit earlier. Now it's your turn. Could you please kindly share your presentation or whatever your experience all the way from Malaysia leading the situation up there? Professor Jainal, okay, over to you.
Thank you. Yeah, thank you, Prof. Sharma. Can you see my screen?
Yes, it is very clear.
Okay, all right. So just is going to, I think first of all, thank you very much. Thanks to the organizer for the invitation. I'm happy to share our experience in Malaysia, and also I think it was very insightful and very informative, presentations from Mr. Gopakuma and Professional. I think there's no need for me to really cover so much on the ESE. So what I'm going to share is our experience, our obstacles, our hurdles. I mean, for the last, I do not know, most probably 15 years, and happy to share that my partner in crime, Professor Chan Lima Gomez, was also part of the I would say you may call it task force, you can call it member, as well, that we have fought against this non-conventional system to be installed in the country. Very brief, I'm going to share, what are the issues, sort of the action timeline and the outcome that we have experienced. And I'm going to most probably brief a bit on the policy paper and also the act that has been put in place. Since I think last year, 2020, early last year. And we're going to give just a very brief, quick takeaway when it comes to the ESE, protection. One of the issues, of course, there are many issues with regards to the non-conventional lightning system. It's not just on the ESE, but I think we are talking about the knowledge. I think pretty much those information have been covered by Mr. Gopakuma, very detailed presentations. So I'm just going to sort of put a statement and brief informations about the knowledge, about the fact that there's no risk assessment that even installation of the ESE and also and so we whatever the information that has been explained in the NFC standard, but when it comes to the interpretations of the local vendor especially, so it shows very much opportunity for the vendors, sometimes to make unnecessary action and also justifications when it comes to the specification and locations to be installed. And also the fact that it was very aggressive promotions of the non-conventional system, particularly on the ESE. And just to share that we have all those non-conventional systems, we have dissipation array system, we have SLE, we have all these CVM, ESE, and all those things, which is based on the basis that it is advanced technology, it is simple installations, and it gave huge reward to the promoter. And also the issues of problems when it comes to the installation and maintenance of the wiring systems. So what happened, I think, with the non-conventional system, particularly on the ESE, it's very easy installations. You just put one ESE, you have one down conductor, and you have one earth pit, and that's it. So no issue at all. And the fact that when you have the system, integrated with the electrical system, the existing electrical systems, and we have seen so many problems that faced by the building owners. And also, we do have issues with our local engineers. So these are all about the capacity buildings. So lack of interest. When we say lack of interest, sometimes when we have like training programs, any platform for discussions. So rarely, we have all those people who are very much, in the related fields, to come and join for the discussions. So it could be due to several reasons. It could be due to cost or fees, and I think most often, due to the attitude, which is very much, I would say that less concern on the issues that the country is currently facing. And we do have, several products, and especially on the surge protective devices that are fake and put on shelf. And in fact, we did have cases whereby we have supplier or vendors or manufacturers from China, and they came directly to us and asked us to endorse, their product. And also, again, there was a product, a SLE product from China that tried to penetrate the standard committee, under the Department of Standard Malaysia, and tried to have the working group, to develop product standard, and also try to try to endorse. And this is due to the huge support from one of the big company in the country as well. And last but not least, due to the administrative barrier, sometimes we do not have an accurate information, received. So just what Mr. Gopal Kumar, explained, that when you have the actual things in the NFC, but when it comes to the translation or interpretation, so there's no accurate information, intentionally or could be unintentionally. So those are the issues. The country was facing at that particular time, and that led to the I would say like strong actions, moved by our Energy Commission of Malaysia. And I think, again, happy to share this document as well, that those informations of the non-conventional system and also the installations can be found from this document. And also just to support the previous statement from previous speakers, that we do have a lot of reports, not just like a couple of reports, but we have many reports, either from CIGRE. So this is from CIGRE, that was published and talk on the non-conventional lightning potential system. And also we have one of the experimental work that was carried out by Professor Vernon Kure in Uppsala, to establish, or rather to prove, the stream is clearly found that there's not more than 10 to the power of 5, which is against the claim that has been made by the ESE vendors. And again, this is one of the experimental work that was conducted in 2002, and they actually have replicated, what the ESE manufacturer has I would say has carried out the same experimental work. So against the same statement as mentioned by Mr. Gopal and Prof. Naga, that there's no superiority of the ESE rod. So the chances would be 50-50, regardless when you have the ESE or when you have the normal rod or normal lightning conductor. So and in fact, I think even like 7 seasons of field testing in the New Mexico, one of the university in the US. They also actually came out that similar thing, that in fact there's no superiority of the ESE as compared to the normal lightning rod. So this is clear evidence of showing the failure of the ESE when it comes to its claim. And in 2009, we had cases. So this is one of the, I would say, key incident that leads to the serious actions from the government. It was what we call the incident that caused a huge problem to one of the government hospital, Putrajaya Hospital, which is located, I would say, less than a couple of kilometers from the federal territories. I mean, the federal building, administrative buildings, and the fact that the what we call the locations of the strike and the distance of the air terminal where the ESE was installed is less than 80 meters, as what the claim made by the ESE manufacturer or ESE vendors. The fact that they can even cover up to about 100-meter radius. So this is a good example. And in fact, before that, we do have what we call the reservoir tank that was exploded in 2006 that caused instantaneously over 100 million Malaysian ringgit, which is about 20 over million USD. That also triggered due to the I mean, they have the ESE system installed. So I think those are the failure. And of course, we have many more pictures, many more evidence to show the failure of the ESE, and just to what you call, to support whatever the claims on their superiority, and also issues on the I would say the global agenda on the disaster risk reductions. And one of the things that why we are so concerned, because when we refer to this framework, and this is particularly on the right hand side, referring to Malaysia, we do not have anything related to lightning. So this is huge challenge for us in particular. I mean, to educate the school children and also the public. We do have everything about the flood, the storm, the haze, and whatnot, but we do not have any information with regards to lightning. So this is among the issues and concern that triggered the local authority, to look into this matter seriously. And for the last, I would say, 11 or 12 years, we have recorded the number of injuries and fatalities due to lightning. And of course, when we talk about the database, one of the issue is we always debated the integrity of the data, but these particular issues or concern are very much discussed, by other scientists as well. So as best as we can, so we try to develop our own database, and we try to indicate in terms of on the yearly basis, because we do have seasonal variations in the country as well, and also we try to relate on the activities when the incident was happened. And finally we came to the conclusions that if you look at the ratio between the injury and also the death, it's not much different. So it's huge as far as the population is concerned. So this kind of thing, and in fact, we are the one who collecting this particular data at the moment, and we trying our best to to help the government in providing to the public safety. And this is, I think, very much the key of the presentations. How we came up with the directive, with the circular, and also with the guidebook. So I think for the last, again, as I said, for the last 10 years or so, we've been fighting. And in fact, I think since 2000, early 2000, huge, we can see here like huge, demand on the ESE in Malaysia. But then after a series of, engagement and stakeholder, finally in 2011, the Energy Commission, which is the local authority under the Ministry of energy at that particular time, has issued a circular but at the moment, at that particular time, it is not compulsory, but rather it is, they try to make it mandatory, but it's quite difficult because they have to deal with the local government, which is from another ministries. But still, we can see several local government who took the initiative and rather stringent when putting the what we call the directions and the rules of the buildings. So whether they like it or not, so the developer has to follow this particular circular. And subsequently, in 2014, again, happy to say that Prof. Chadima was also involved in this particular project. Malaysian has adopted the IEC 62305 at that particular time based on 2006 edition, and we have developed a very, I would say, so-called easy guide. It is a cross-reference to the 4 versions of 4 series of 62305. And then recently, early last year, whereby the paper that it was a motion by the energy commissions, and they put into the cabinet, and that paper has been approved by the cabinet, and it became legislative. And in January 2020, that particular we call it the directive or policy paper has been put in place and become mandatory to be followed by all the practitioners, whether they are the building owners, the association of the consulting engineers, and any developers. They have to follow that policy paper or that directions. So I'm going to share a bit the contents of this directive. So it was approved by the cabinet, the fact that because it is related to the Electricity Supply Act 1990, our own act on that, and it became mandatory to be followed. And again, as I said, the applicability of the directions of this policy paper is to all the competent person, to all the electrical contractors, consultants, building owners, and also managements. So all the contents and all the informations are clearly stated in this document. It's local in the native language. And enforcement, we gave like a buffer time of 1 to 2 years, depending on the situations of the buildings. But in general, this enforcement applicable to all the existing building and also the building under the constructions. So the existing buildings, they gave like 1 year at that particular time. So it was expired early this year, that they have to follow. If they have the ESE or any conventional system installed, they have to remove it and they have to properly do the risk assessment, IC 62305-2. So for those buildings who are in the constructions or in the pipeline, about to be developed, so they have instantaneously they have to follow this enforcement and also this directive. And what happens, if those people, if those this competent person or the contractor or the building owner fail, to commit, to this new rule, so there will be an offense, and there will be a fine of 200,000 or 50,000 USD, or imprisonment for the term of not exceeding 2 years, or both. So this is how serious the government considered the issue with regards to the ESE and other non-conventional system. So finally, we are so happy the fact that all the standards also have practices, and I think so far we have seen a good engagement and also I would say the adherence to this particular document, which are currently active and in place. So we are glad to see that, and I'm happy to share that from now on there's no more ESE or any non-conventional system to be installed in the country. So it's very clear, the enforcement is very much active and currently taking place. So my last slide. What would be the quick takeaway for those building owners or for those engineers or consultants prior to the LPS installations? So there are a couple of questions that we, either you are the engineers or we are the scientists, that we need to, of course, give an appropriate answer to that. The first thing is whether the consultant and owner understood on the principle of lightning protection system. What are the components involved? What are the lightning protection levels and so on? So what are the needs to carry out the risk assessment and so on? So what are the standards involved with regards to this lightning protection system installations? And then we need to know whether the proposed system, what we call the has been approved by any international standard. So having said that, when it comes to any international standard, either we are talking about the IEC. And I think NFC is very much on the product standard. But even as mentioned by Mr. Gopakumar, it's very clear that even whatever the statement in the NFC, it's not being rightly, I would say, practiced, or rightly translated when it comes to the installation of the ESE devices. But again, we are very much looking into the approval from. It's not just IEC, but also we are looking into the IEEE, the C-grade NFPA, and so on. So which are all against the non-conventional system. As mentioned, rightly mentioned by Prof. Naga Bhushan, I'm more than happy to endorse or to accept if those system has very scientifically proven evidence on showing whatever the questions, whatever the issues that we have raised. Academically when it comes to their claims. And the third one, we need to know that whether there is any technical or scientific evidence, to support the claims. So this is one of the, I think critical things, for the last, again, decade that the scientists have asked these ESE manufacturers and also vendors to support or try to present their outcomes and also to provide, any supportive evidence to support whatever the claims that they have made with regards to the ESE devices. And last but not least, what are the costs should be spent? Because what happens is that most often, this is our experience, sometimes when you have the the cost of the ESE, which can be 100,000 ringgit, or say for example like 25,000 USD. And the fact that, what vendor tried to educate the building owner, say that, okay, you don't have to install the, the normal system because it costs you a lot. It's very difficult to manage and so on. So the fact that, we have so many options in the standards, whether you can use copper, whether you can use GI, aluminium and whatnot. So those are the options which can, again, we can sort of compromise in terms of how much the cost that we should spend. So those are the things that I think we as a practitioner or you as a consultant, engineers, I think you should ask yourself, prior to install, prior to go for any lightning protection system installations. Then I think we are more, after that, I think we are more than happy, to go for whatever the recommended as per international standard. So I think that would be my quick, sharing. But I'm happy to, to share or to answer any questions into detail of, how the country like Malaysia, managed to, come out or managed to, come out against this non-recognized lightning protection system in Malaysia. I think it took, of course, a lot of effort from us, a lot of, platforms for the discussions, a lot of before we finally came to the decision, we finally came to the success story that I've shared today. So thank you very much for the opportunity. I pass to you back, Prof. Sharma. Thank you very much.
Thank you so much, Professor Jainal, and I salute you on behalf of South Asian Lightning Network as well as a student of lightning physics. That you are the hero who could endorse such a scientific based lightning protection system in Malaysia, and you are the leader there. So I have no words to respect your efforts to tell here. But anyway, this is my regard. Now, I would like to, before I go to the interaction and question answer, I would like to invite Professor Chandima because I know him very well for very long period, almost 2 decades, and for some time in the beginning, like 2003, 2004, Chandima, some people were telling that you are advocating ESE devices, and now you advocate this IEC standard all the way maybe for 15, 16 years. So what is your experience, Professor Chandima, regarding this lightning protection system? Professor Chandima.
Thank you very much, Sri. Actually, you asked a very good question. I mean, for the last 20 years, maybe about last 18 years, I was in the forefront of educating people against the lightning concept. And one positive point, advantage I have in this regard is I have no personal grudges at all against this technology. The simple reason is that I myself was an ESE inventor in the early 2000s. Just after my PhD, I was so enthusiastic that according to the NFPA, the French standard, I developed an ESE device, which is in the market, I think, still, but I abandoned my own baby when I found that the technology is sheer rubbish. So let me take very short period, a few minutes. One thing I can tell all of you is that actually there is a war that we have declared against ESE proponents, but in the present context, if everybody can think well, we don't need a war. Actually, one individual, one single factor can negate all the claims of ESE proponents. Just one single scientifically observed, scientifically proven fact can totally destroy the entire claims made by the ESE proponents. What is that? As Prof. Naga Bhushan very clearly shown you, and it was in Mr. Gopakumar's presentation as well, how do the ESE manufacturers and the French standard is going to calculate the length advantage? That is, they multiply the length, the time advantage, delta t, into 10 to the power 6. And this 10 to the power 6 is very arbitrarily taken as the speed of leader, the answering leader going from the building, as a constant factor. And don't forget that this has been taken in the mid 90s or early 90s. And there was no scientific proof at that time for taking this value. They just taken it. So for an example, if the time advantage is T, capital T, then the length advantage over the virtual height of the air termination system, they say T into 10 to the power 6. Now, after 25 years, today, we have very sophisticated, high-speed, high-resolution video cameras. Now, for the last 3 years or 4 years, there were extensive studies went on in Brazil and in South Africa, in Johannesburg, on measuring the speed of answering leaders with these sophisticated cameras. And the result, now it is published in very high impact factor international journals. The speed is 10 to the power 4 meters per second. Now imagine if you multiply the time advantage t by 10 to the power 6, you get 100 meters. But actually the speed of the answering lead is 10 to the power 4. So that means if the acclaimed time advantage is there in the ESE products, still the length advantage is 100 times less. So if they claim that they have a 150-meter height advantage when they have an ESE rod of 1 meter, according to the now proven and firm, solidified scientific facts, the actual virtual height is 1.5 meters. And for 1.5 meters, are you going to pay several lakhs of rupees? Instead of that, you can very easily have a copper rod of that height, isn't it? So with this point itself, I think we can demolish the claims made by ESE proponents. I challenge anybody in this audience to just raise your hand and challenge this argument. I'm very happy to answer. And the second point I would like to say is that Mr. Gopakumar gave, I think for the first time in this IDAO war against ESE devices, I listened to, actually, I have seen this presentation yesterday, or day before yesterday, as Mr. Gopakumar, Dr. Sriram, and I had a personal meeting. It was the first time I have seen that somebody is very clearly pointing out that there is no difference in the French standard and IEC 62305 except for the attraction radius of the ESE device. So apart from that, all other parts of the lightning protection system should be exactly the same between IEC standards and the French standard. So now, when we have done surveys in countries like Sri Lanka, Bangladesh, then Malaysia, and so on, we have found that most people, 90% of the people who go for ESE technology just select that option because of the cost. They think that this is one of the major points that the ESE vendors put forward. The cost of ESE system is much less than the cost of IEC standard designed lightning protection system. But now the thing is that if they are sticking to the French standard in the installation, the only difference is instead of, say, 10 copper rods or aluminium rods that we install in a building, maybe 2, 3, 4, 10, 12, the ESE people install only one ESE rod. And now if you look at the cost of the ESE rod, I'm sure that you can buy 100 copper rods with that price. Okay, so in order to fool the public, what the ESE manufacturers do is, instead of going for the French standards, which actually the Bible of the the ESE technology or the ESE standard, they just develop their own ways of doing that and have one ESE rod and one down conductor. I think I will stop at this point. You see how much these people are fooling you. So, I mean, unfortunately, I may say, it was only Malaysia who could make, the scientific community could make the government accept or convinced that this ESC technology is a nonsense, so that the government came up with these strict regulations, thanks to my brother Zainal, and there were several people in this regard. So we were successful in Malaysia, and we are trying to do the same in several other countries. Hopefully, we will be successful in the future. Thank you very much, Sri, for offering me this opportunity.
Thank you so much, Pras Channima. You are here all the way from South Africa. So yeah, wonderful experience from almost 2 decades back. Now I have seen Dr. Muralidas, who was very extensively involved in this education, lightning protection and awareness raising. So may I invite Dr. Muralidas to have some comments?
Yes. You see, I'm a person who has worked in both fair weather atmospheric electricity as well as in lightning. Therefore, for me, this early streamer is something which it's simple for me to say that such a thing will not work. In lightning, there is what is called global electrical circuit. When you have a circuit like that, where lightning is a part, does the function of a generator, and in this circuit, you put something and say that I can produce a longer streamer, early streamer. This is simply nonsense. The reason why these people are able to advocate and sell these things is, even in +2 level, when people are taught this static electricity and electricity, people get confused with static electricity. So people are under the impression that this lightning is all about static electricity or something like that. When they don't understand, it is convenient for these people to sell all these early streamer devices and what is that, neutralizing devices and all that. It is known, very well known, that there is no difference between different kinds of trees. For example, you have palm tree and a jackfruit tree. There is no difference in lightning strike because of the shape. So you have a different shape lightning rod and say that it will send a streamer up. Or even if you have a circuit inside, you cannot have a streamer sent up. Never. This is something for people like me who had to do sensors for atmospheric electricity, fair weather electricity, and lightning cloud field measurement. It is something which we can easily understand. So the problem is, for the common man or the people who don't know, what they do is, if next door buys an ESE this thing, I will also buy that. But lightning doesn't come daily. So these people have the advantage that they will keep on selling. Myself, Mr. Gopakumar, Professor Naga, Bhushan, and Professor Chandima Gomes had gone for a workshop in, I think, in Bangalore. So some people had come from Chennai. They were saying that they were being sold these ESE devices at a cost of 3.5 lakhs in 2006. At that time, the installation of a normal lightning rod system would have cost only 15,000 rupees. Why are they able to sell? First of all, lightning is not a regular phenomenon. Second thing, people don't know how exactly it works or what it does. At the same time, these people, the buyers, never adhere to Bureau of Indian Standard, which is it is very bad. I have seen that Malaysian effort to have in 9 years, they were able to bring it out as a regulation. I think this effort by this group and to say that this ESE is a nonsense is very good. I think we should continue it, and probably if we continue like this, maybe we will also be helpful in bringing out a regulation, and that is the only thing that can work finally. Very good. All the presentations are very good. Most of all the presentations are based on experiments, the result of which shows that ESE is a nonsense. I think we should continue our effort. Very good presentations, and thank you.
Thank you. Thank you so much, Dr. Muldas, for your nice words and your wonderful experience working with the static electricity and lightning. Yes, I understand that today the participants and all the audience here got to know very well about these fraudulent claims from the proponents. Thank you so much, Dr. Muralidas, again. Now I would like to invite Mr. Gopakumar for taking up some questions. There are not many questions. Would you take up the questions by yourself, Mr. Gopakumar?
Because it looks like there is not much question. I can't find any questions.
Not much. Couple of questions, but we can always send a link, a video link to the people or participants here, isn't it?
Yes. The people, for your information, for all the registered participants, once when you open up the Teams app, you will be able to see all the comments, and in the comment, if you look at the chat in the Teams app, at the top of the chat, you will be able to see all the files which we uploaded. Files in the sense their documents, like the different study reports and other documents are already uploaded. You can see that there were also some video links. I've shown that the people are educating wrong things about lightning. So those videos are also put on the chat box. You can download it and see it. So by this, probably Dr. Nagabhushana sir, any final words from you?
Yes, I would like to add a few points, Mr. Gopakumar. Some of the points were raised by you. You mentioned a test report from CPRI on the current carrying ability of the ESE rods. I have seen the report myself. They have passed the current through the down conductor essentially, or not through the air terminal, but the rest of the conductor. If any of the people are interested, let me tell you, even a 8 millimeter diameter copper rod can handle up to 200 kiloamperes. We have done it many times in our lightning test facility. Regarding the lightning test facility, I must mention that we were funded by Aeronautical Development Agency in 1989 to set up a lightning test facility for testing of aircraft components, mainly light combat aircraft, Tejas. We have got up to 4 megawatts generator. We can go up to 2 megawatts at the moment because of certain other restrictions. If anybody is interested in carrying out the experiments, we will be happy to conduct the experiments and show them the performance of the ESE rod or the ordinary Franklin rod. I would welcome them. That's point one. Point two is the current test capability. We can pass 200 kiloamperes through the air terminal of the ESE and see if they are interested. We can show them whether it can stand it or not, because there's no use sending it through the 80 square millimeter down conductor. There's no use at all. The air terminal also must be capable of doing that. And then the most important thing, one of the important things regarding this 10 to the 6 meters per second is that might be the velocity at the initial point of initiation, where the electric field intensity is the highest. Remember, the velocity will be dictated completely by the electric field intensity. That's the driving force. As the electron or as the passive ions move away, the electric field gets reduced drastically. It's inversely proportional to the radius of curvature, at least for some distance. Afterwards, it will remain at a very low level. Therefore, the velocity goes down from 10 to the 6 meters per second. It is highly debatable. But if any of them want the test to be done, we can do it. We can go up to about 3.5 meters gap spacing without much of a problem. I would like to welcome them. But I would also like to mention at this point, the whole proceedings have been very nice. I enjoyed it. Professor Zainal, apart from Mr. Rob Kumar, Professor Zainal's presentation, and then Chandima's presentation, and then who else? Muralidas, of course, is a very good friend of mine. They made very interesting presentations. The only thing is, our general public must be made aware of the reality and not simply by the vocabulary of the impressive terminology of these people. That's all I wanted to say. Thank you once again. It has been a wonderful opportunity for me to come back to this subject in a formal way. Thank you, Gopakumar. Thank you.
Yeah, thank you very much, sir. So I think few people had raised their hand. Probably instead of chatting, they have some question. I would like to unmute Mr. Vinay Nagdio. He is our member in the our expert committee, technical committee of Vidyut Surakshit Bharat. He is a retired superintending engineer from the Electrical Inspectorate of State of Maharashtra. Sir, you can unmute and speak. You have raised your hand. You can unmute and speak, sir. You have to unmute first. I think he is not there. Then also I could see a name PC Kalra. I would say probably this is Dr. PC Kalra. Sir, you have raised your hand. If you have any questions, I am unmuting you. So you can, if you have any question, you can unmute yourself now and you can speak. Also a question from Mr. Raja Ganapati and Mr. Muralidhara.
I have a question. Now we talk about lightning surge of 200 kiloampere. Now this thing, when I'm designing a house in a town or a small building, say in an area, do I need to consider protect my building for a lightning surge of 200 kilometer? Transmission lines, even most of the transmission lines in a sub-distribution system have a lightning arrestor of 9 kiloampere. We had been making buildings and protecting our system with the Franklin rod. Now, I want you people to define which are the building or which are the installation which need to consider 200 kiloampere or 9 kiloampere or 20 kiloampere. These things, should be categorized so that we don't spend too much money for nothing.
Mr. Gopakumar, can I answer that question?
Yes, sir.
I don't remember the name of the gentleman who was speaking.
PC Kalra.
Mr. Kalra.
Dr. Kalra.
Dr. Kalra, I would like to elaborate like this. The 10 kiloampere surge arrestor that's used on power transmission systems is for carrying the current resulting from a lightning stroke the transmission line conductor. There the highest current estimated has been up to about 100 kiloamperes. Therefore, if you see the standards, you will see that these surge arresters are supposed to withstand 2 shots of 100 kA, wave shape of 4 microsecond by 10 microseconds. Rise time is 4 microsecond, tail time is 10 microseconds. Now, the current of 200 kiloamperes we are talking about is a current which flows through the down conductor. As I told you earlier, a conductor of approximately 8 millimeters diameter copper can carry this current. The temperature rise being 300 degrees momentarily for a few seconds in still air. In normal air, the temperature will drop down very quickly. So if you think of, say, 10-15 millimeters diameter conductor, it can very comfortably handle 200 kiloamperes. You don't have to be worried at all. A standard lightning conductor, Franklin rod, will be able to handle it very comfortably. There will be absolutely nothing to worry. In fact, the two are totally unrelated. In the case of power systems, a 10K arrestor that's called what's called the rated current or the nominal current rating of the arrestor. That's a 8 microsecond by 20 microsecond wave shape. Whereas high current, it is rated for 2 discharges of 100 kA. It can handle that. There's no problem about that. I hope I have clarified. If you still have doubts, I will be happy to answer that.
No, my question is that 100 kiloampere discharges, do I have to design every building for 100 kiloampere?
No, you don't have to.
I am designing a small building where there is a sub-distribution board and a few dBs. Now you want me to install some surge arresters on that. Do I need to install surge arresters of 100 kiloampere or 12 kiloampere? So I mean, those you have to define where do I need 100 kiloampere, where do I need 200 kiloampere, and where do I need 12 kiloampere.
Sir, these are very well defined in the ISI.
The voltage surge you will get inside buildings like that are due to induced voltages, not due to direct voltage. Therefore, the currents will be very, very small, maybe the order of a few kiloamperes. That's all. You don't have to worry about that at all. If you use the standard, if you follow the standards, you'll be more than safe. Nothing to worry about that part.
Sir, what I'm saying, does demography makes any difference? I know I used to stay in Chicago. There used to be very loud thunderstorms almost every day. So, say upper hemisphere, north sphere and south sphere, you can have isochronic level can be very high, but demographically, I feel that you can specify that which are the areas to need this kind of a surge arrestor or lightning arrestor.
For surge arresters inside residential buildings, you don't have to worry about at all these currents of 100 kiloamperes or so whatever it is. Few kiloamperes will be more than adequate because they are always, the currents are due to indirect lightning, not due to direct lightning at all. You just don't have to worry about that. But if you, whatever you said about Chicago is different. See, thunderstorm is right, thunders are right. But typically, if you take the isochronic level map of India, in IS there is, I don't remember the number very clearly. What is that IS number? Huh?
Anyway, whatever the number. No, I
you
think
don't,
building like the Google Center, the Google Data Center, and some buildings, say hospital in say Delhi, they don't follow they shouldn't follow the same standard and same high surges. I know the Google Data Center is a very high value property and they can protect themselves against the worst situation. But a small hospital or a school in a town area, they don't need to protect themselves against such heavy things and spend money.
Right.
Sir, these are very much explained in the risk assessment, sir. If you do a risk assessment, all these questions will be answered. So a small building, you have to do a small protection. A high cost building, you have to do a high insulation. This is there in the standard. And the rating of surge arresters are also given in the standard.
Mr. Gopakumar, can I add something about that question, please?
Yes, sir.
You see, when the typical return stroke current, and I say typical, you can say the average also, it is about 15-20 kiloamperes. The maximum current can be 100 kiloamperes. So when you say typical or average and then maximum, that means 100 kiloamperes comes in once in a blue moon only. But it is rare. There is no necessity for you to design for the maximum always. So, and another thing is that the damage that is done in fire accidents and things like that is done by what is called the continuing current, which happens in the second stroke on or so, and lasts for several hundreds of milliseconds. The burning of holes in metal, etc., is done by the continuing current. So that is only a few hundred amperes lasting for a longer time. Summing up, when you do a design for such an accident, this thing, etc., you do for the average or typical value, and you cannot design for the maximum. Maximum is about 100 or 200 kiloamperes. There is no necessity to design for the maximum because you don't expect always that to happen. For example, if you have 1% of the population having a particular disease, you don't have to worry about it. When it crosses to 30 or 40%, then you start worrying about it. But similarly, I would say if I am in your place, in your shoes, I would design for only for 15 to 20 kiloampere, whichever be the building. So all the standard protection systems and conductors, etc., will take care of that. And even if it 100 kiloamperes comes, all the systems, that system protection system may burn out, the wire may burn out. That is all. But the rest of the things will be protected.
Okay.
So thank you very much, sir. Thank you very much, sir.
I had just one small question. Now, on the sloping roof of the metallic roof, most of the time the client doesn't want to put the strips there. He says, I don't want to puncture my sheet. And even the down conductors of the building, high-rise building, the architect doesn't want to see any visible conductor. And the architect doesn't want to see too many spikes on his roof. Now, how do you mitigate the aesthetics with the technical requirements?
They're very simple, sir. Very, very simple. Nowadays, a lot of buildings have got steel handrails. The steel handrail can be used, or some steel structural architectural things. So those can be used. So as you said, in the construction industry, routing down conductor is always a big question. But it doesn't mean that since it looks it don't looks nice, we should not show down conductor. So in a lot of places I know that instead of 10 down conductors, 2 groups routed through 2 shafts. These things will not work. But it is anyway, as lightning protection engineers, or we have to strictly follow the rules. So thank you, sir. Thanks for the question.
Okay.
So I have Mr.
Thanks.
Jai
Thanks a lot.
Patke.
Thanks a lot.
Thank you, sir. Thank you.
Okay.
So Mr. Jai Patke or Mr. Ilam Peruma. So there are few people who had raised their hand. I think if there is no questions, probably Dr. Sriram, we can close the event.
Yes, I think the protection system itself is very well documented in IEC 62305. So I would request all the participants to refer to the document. If not, you have Indian standard where everything is explained very well. So I request all you to refer to the standards. So with that, if you have any further technical issues or questions, we can answer them, but through the mail. So kindly stay in touch, and with this, I would like to close this session because we are running almost riding over the time. So may I request all of you to kindly be in stay and close the session. I think we should just stop this presentation.
Yeah, thank you very much. And finally, very big thanks to Dr. Sriram for nicely managing it. Thank you very much. So the event is going to a close.
Thank you very much. All the best to all of you. Very happy season. Thank you. Bye.
Thank you, sir. Thank you, sir.
Bye-bye. Have a good day.
Thank you, Chandima. Thank you, Muralidhar, sir.
Thank you all.
Professor Sriram, Professor Chandima, Professor Dr. Muralidhar, Professor Zainal. Wonderful being with you, of course, on the line. It has been a delightful experience. We hope we'll have some results. Thank you.
Yeah. Thank you, sir. Bye, sir. Bye.
Stay safe all. Bye.